Since the development of radar in World War II, aircraft can be detected from hundreds of miles away. Radar can also be used to guide deadly anti-aircraft missiles with pinpoint accuracy. Stealth technology camouflage aircraft from radar, just as camouflage paint was designed to hide aircraft from enemy view. Radar works by projecting a focused beam of electromagnetic radiation, which bounces off the aircraft back to its source. This reflected energy determines what the radar can and cannot see. As soon as radar was developed, so began the efforts to thwart it. Bombers would drop thin strips of aluminium foil called chaff. These strips, carried by the winds, formed huge clouds on enemy radar screens, making it impossible to determine the precise location of the attacking bombers. By the 1950s, technological advances allowed radars to see through the obscuring clouds of chaff. Electronic jamming equipment was soon developed to disable enemy radar by overwhelming the reflected radar signal with a stronger false signal. But every new technology triggers a countermeasure. By the 1970s, jamming could be evaded by new frequency-hopping radars. A strange little missile of the early 1960s suggested another approach to avoiding radar detection. The Quail decoy missile highlighted that the visibility of an airplane to radar was determined as much by its shape as its size. Certain shapes, such as 90-degree corners, concentrate radar signals and reflect them strongly. The Quail exploited these features so that it would appear as large as a B-52 bomber. The B-52 bombers could launch several Quails on false headings, confusing the enemy as to the size and location of the real bomber force. As it was shown that the shape of an aircraft could vastly increase its radar signature, so began the hunt to achieve the opposite effect, an aircraft that would appear smaller or even disappear from radar. This search led to low observability technology called stealth. One of the first aircraft to feature stealth technology was the Firebee unmanned reconnaissance drone. Surfaces that reflected radar strongly were hidden deep inside the airframe. This robot spy plane also included a new type of material for its skin called RAM, meaning radar absorbent material. RAM soaks up radar energy like a sponge, making aircraft virtually invisible to radar. In 1966, another spy plane appeared in the US Air Force, the legendary Lockheed SR-71 Blackbird. The SR-71 was one of the first manned aircraft to employ stealth technology. Although the Blackbird was not invisible to radar, its use of radar-absorbent material helped reduce its visibility. Another example of low observability technology is the B-1B Lancer bomber. The original, the B-1A, had a radar cross-section of 10 square meters, 10 times less than that of the older B-52. Advances in radar-guided missiles led to the B-1B. The B-1B version has a radar cross-section of about 1 square meter, 1/100th that of the older B-52 bomber. The success of the B-1B program proved that stealth technology could greatly reduce an aircraft's visibility to radar. But the challenge remains to design a plane that was virtually undetectable. Anticipating the need to incorporate stealth technology into future fighter aircraft, in the 1980s, the US Air Force began the selection process for an advanced tactical fighter. The crucial factor of an aircraft's stealth ability is its shape. The main attraction of stealth fighters is nearly impossible for the enemy to target. This gives a fighter with stealth characteristics the ability to fire many of its long-range radar-guided missiles well before the enemy fighters can even detect its presence. Stealth technology is not a magic potion that makes a plane invisible, but through careful design and combined technologies, the optimum mix of performance and stealthiness can be achieved. And the Raptor has the most stealth features of any fighter aircraft. The Raptor carries its AIM-120C AMRAAM missiles internally to preserve its stealth qualities. Missiles are launched through hydraulic arms that deploy the AMRAAMs so quickly that the weapon's bay doors are open for less than 1 second per launch. The Raptor can fly supersonically in supercruise mode, reducing fuel consumption and avoiding the high heat signature associated with the use of afterburners. The first FA-22A Raptor was delivered to the US Air Force in January 2003 and entered service in 2004. The Raptor is intended to replace the F-15 Eagle, an aircraft with an undefeated 104-0 fight record. The US Air Force expects the Raptor to continue this impressive record well into the future. In the late 1970s, the US Air Force set out to take the technology further, launching a secret project named Project Senior CJ. The results are evident in this remarkable aircraft, the Northrop B-2 Advanced Technology Bomber, later named the Spirit. The development of the B-2 was one of the best-kept secrets of all Air Force projects. Much about the Spirit remains clouded in secrecy even today, including exact information about the plane's radar cross-section. Similar in size to the older B-52 bomber, the B-2 is likely to be several hundred times less visible to radar. It is impossible to make an aircraft completely invisible to radar. However, its radar cross-section can be reduced to such an extent that its radar reflection cannot be distinguished from normal background radiation.